Alright, hey everybody. In this video I'm going to go through some examples of solving series and parallel circuits. These examples are similar to the ones that I did in class. They're a little bit simpler maybe, and I'll go a little bit faster through them. So if you were in class, this might be a good thing to watch to review. And if you miss class, this would be a good thing to watch so that you understand how to solve these types of circuits. So let's get started. The first type of circuit I'm going to do is a series circuit. And I'm going to start by sketching that circuit. I'll start off with a battery. Let's make that a 12-volt battery. And then I'm going to place two resistors in series with that battery. Okay, and I'm going to make the resistors have different values, and so I'll make one resistor small and the other resistor big. Okay, now what are the types of things here that we're going to do with this? What do we mean solve a series circuit? Well, what we really mean by this usually is that each resistor is going to have its own R value, it's going to have its own current, and it's going to have some type of a voltage that gets used on it. Okay, some type of a voltage. And so, we're going to have an R1 here, and I'm going to just say that this first resistor, we're going to give you a value, right? Let's make it 3 ohms. And then we're going to have to figure out these other things, okay? Now, before we can do that, we need to know about the second resistor, and so this is going to be my R2. And then there's going to be a current and a voltage, okay? Why don't we make R2 equal to 6 ohms, right? Because it looks like I made that resistor look bigger, so let's just make it bigger. And then we can go ahead and solve for the things that we need. Okay, so a lot of times in problems you know the battery voltage and you know the two resistances, or the 3 or the 4 or whatever. Okay. So to find out the rest of the stuff we need to apply some physics. Okay. One of the things that we'll always need to use is Ohm's law. I'm going to write that up here. I think we put that in a triangle before, but I'm just going to write it like that. And so if we want to solve for things now, if we want to find the current, right? Well, it looks like current would be equal to voltage over resistance. So Ohm's law tells me that's how I find current. Now guys, let's think about this. This is a series circuit, and the current is always the same value no matter where you are. So if I put a current meter up here, I should measure the same current as if I put it down here. Or if I put it in between the resistors, I should still get the same current. So how do I find that current that goes through all those resistors? And the way that you do it is that you use this Ohm's law, and you take the battery voltage of 12 volts, and then what you do is you have to divide it by the total resistance of the circuit. All right, the total resistance. And in series, the way you find total is you add up the individuals. So you'd have 3 ohms plus 6 ohms. So my current is going to be equal to 12 volts divided by 9 ohms. And of course, if you simplify that, I guess that's a fraction, right? That's 4/3 of an amp. I guess that's okay. Now, that's a little bit of work off to the side, right? But now we actually found the current through resistor 1, and we also got the current through resistor 2. In other words, those are the same. And they always will be in a series circuit. So if you have to find current, you have to look at the total resistance, and then you have to use Ohm's law to find it. Okay. Now, the last thing we have to do here is to find out how many volts are getting used up on each resistor, and you can think about that. I think if I'm pushing electricity through two things, one of them has a low resistance and one has a high resistance, I feel like we're going to use more voltage on the big resistor, the big one. And I feel like we're going to use less resistance on the small one. And so let's see if Ohm's law tells us that. So if I want to find the voltage across resistor 1, okay, let's see, I'm going to go back up to Ohm's law. Voltage is equal to I times R, so my voltage across 1 is equal to my current times my resistor 1. And so that's going to be equal to 4/3, right? I'm getting it from there, times 3 ohms. And so I use my total current and I multiply by the specific resistance that I have in the circuit. So 4/3 times 3 is 4 volts. And so that's my 4 volts, okay? Got it. Now, for V2, I'm going to take a shortcut because I know that the battery gives me 12 volts, right? And I know that one resistor uses 4. And I know that the other resistor must use whatever is left. In other words, this voltage should be 12 minus 4. It should be 8 volts. It should be, right? And if you want to be sure that it really is, you can prove it to yourself by, again, doing this math down here and saying V2 is equal to I times R2. Again, 4/3 of an amp. This time times, what is it, 6 ohms. 4 times 6 is 24. 24 divided by 3 is 8. And so, yeah, that's great. So I get the same 8 volts both ways. Okay? So this is how you do stuff in a series circuit, okay? And we started off with the voltage and 2 resistances, and we got everything. Now, you're going to see problems sometimes where I give you maybe a voltage and a current and another resistance. And so I'm not always going to give you the same information, but things are related in this particular way that we talked about in the example. So hopefully that would help you. Okay, let's do an example of a parallel circuit next. And in my parallel circuit, I'm actually going to use the exact same values of things I used earlier. So I'm going to put my battery up top here. Here's my 12-volt battery. But then I'm going to run down and I'm going to put my resistors across. Okay? So this is my 3 ohm resistor here. This is my 6 ohm. Now, this is a parallel connection, okay, because you can see that both sides of the batteries connect to both sides of the 3 ohm, but they also connect down to both sides of the 6 ohm. That's what makes this a parallel circuit. Okay, and what I'm going to try to do here again is to kind of work through and find everything I can. Now, since this is parallel, oftentimes what we do is we kind of work our way through in this sort of a way. I don't know if that matters so much, but we want to know voltage and current and resistance for each of these things. Hey, by the way, guys, this is called a branch. So if I say that I want to know the voltage across this branch, I'm talking about this voltage right here. Or if I say I want to know the current through this branch, I'm talking about that. So a branch is kind of like a path that the current can follow. So you've got this branch. You also have a branch here. So I might use that word just so you know what it means. All right, so let's go through and see what happens here. So parallel circuits are like really sweet because that 12 volts is going to be put across both of the resistors. And so right away, you can write down 12 volts across this branch, and you can write down 12 volts across the bottom branch. Sometimes students get a little bit confused by that, but in a parallel circuit, that's the rule, that whatever pushing the battery does, it pushes equally across these resistors. That's because of the way they're connected here. Okay? All right. Let's look at the resistances. That's easy, right? Because this resistor, we'll call it R1. That's equal to 3 ohms, because I told you. And let's look at this this resistor, of course, is equal to, this is R2, it's equal to 6 ohms, so I just copy that down. All right, so that leaves us with current, right? So let's go back up to Ohm's law. At this point, we've got to use it. And if I want to find current, I divide voltage by resistance. So I'm going to do that here, and I want to find the current through this branch. And so what I'm going to do is I'm going to take my 12 volts, and I'm going to divide it by my 3 ohms. And of course, 12 divided by 3 is 4 amps. So I now know that I have 4 amps that are moving right through that resistor. How do I know it's going from left to right? Well, that's a longer story. I could tell you later. It doesn't matter too much right now, but that's what I got. Now we go down to the second branch, I2. That's going to be 12 volts, except this time divided by 6 ohms. And hey, 12 divided by 6 is actually equal to 2 amps, right? 2 amps isn't so fast. 2 amps is less than 4 amps. Did I make a mistake? And so maybe you should think about that, right? Why did you get 2 different numbers here? But if you think about it, it should make sense. Because I have less current going through the bigger resistor, 2 amps and 6 ohms, right? And I have more current going through the little resistor, 4 amps through 3 ohms. So this actually does make sense. Okay. All right, we're almost done here. There's one other current that I didn't label on my picture, and that would be the total current. All right, so it turns out that you have current that has got to go through the battery, and it's got to split up to give me the 4 amps and the 2 amps. It's like a river kind of like coming around and splitting into two separate, like it going off in a splitting 2 ways. And so I hope you can see that, like, if I've got 4 amps going this way and 2 going that way, that I must have a total of 6, right? Because I have to take the 6 and divide it up. So sometimes we kind of write this off to the side and we say, well, what's I total, right? And it would be equal to whatever current you have in the top branch, your I1, plus whatever current you have on the bottom branch. And if you have more than 2 branches, you just keep adding. So we would have 4 plus 2. And so that's where you're getting 6 amps. Okay? Cool. There is one last thing that we could get here from a parallel circuit, and that would be the total resistance of the circuit. Now, this is a little bit weird at first. What does that even mean? But what that means is, like, what if I took this whole circuit, right? And what if I kind of simplified it into this? Right? What if I could take these 2 resistors and just make them look like 1? What would that be? What would the value of this thing be, right? And so, so in other words, if you simplify it, what would this become? Okay. So the easy way to find this, again, is to use your Ohm's law. So we take the R. R is V divided by I. But you have to use the total I here. And so this would be 12 volts divided by 6 amps. Okay? And of course, 12 divided by 6 is 2. And because it's resistance, this is ohms. And so I'm just going to say that, like, our answer here is that R total would be 2 ohms. Now, you might think that's kind of weird because, hey, this resistor was 3 ohms, and this one was 6 ohms, and we're coming up with a combination of 2 ohms. It seems like it shouldn't make sense, right? But in a parallel circuit, it does. Because every time you add another resistor, you make it easier for electricity to get through. I think we talked about the idea of opening up lanes in a supermarket. Every time the manager opens up another lane, the resistance goes down because it's easier for people to get through. So 2 ohms actually should be smaller than 3. It should be smaller than 6. And so it does make sense to have that. Okay? All right. One last example. This is a shortcut for parallel circuits. I'm going to do it fast, and I hope you watched the previous example of a parallel circuit so that you understand this. But what I want to show you is that if you have well, let me just write this, okay? Let's say that you have a 18-volt battery with a 6 ohm resistor, okay? Now, if I ask you what's the resistance of that circuit, right? You're going to say, well, it's 6 ohms. You'd be correct. Okay, let's now take the 18 volts again, and let's put 2 6 ohm resistors in place, okay? And what if I said, what is the R total? Okay, now if you've been paying attention to the last example, you know that the R total should be less than 6, right? Should be less than 6. Well, what's it going to be? Well, let's see if we can figure this out. Ohm's law says that resistance is equal to voltage divided by current total. I'm going to do this math pretty quick. My voltage is 18 volts. Okay, and my current through this resistor is going to be 3 amps. 18 divided by 6 is 3 amps. And my current through the other resistor is also 3 amps. And so my total current here is 6 amps. 3 plus 3 gives me 6. Now guys, what I'm trying to show you here is that 18 divided by 6 gives me 3 ohms. So if I take 6 ohms and 6 ohms, the total resistance turns into 3. It's like I just took 6 and I divided by 2, right? So 3 is also known as 6 ohms divided by 2, right? So I wonder if this is a shortcut. Maybe I didn't have to do this math right here. Maybe this wasn't necessary. Maybe I could just take the resistors and divide. So let's do one more example here. What if I have, let me do 3. They're all 6 ohms. So 6 ohms, 6 ohms, 6 ohms. Whoops, that's an ohm. 18 volts. What I'm telling you is that I'm going to guess that the total resistance, our total, is just going to be 6 divided by 3. I'm going to guess it's equal to 2 ohms. I'm going to guess, right? That's my shortcut, right? 6 divided by 3, that's super easy. So does it actually work? Well, think about it. Every one of these branches is going to take 3 amps of current, right? For the same reasons before. 18 divided by 6 is 3. So if I use Ohm's law and I want to prove this, I would take our total is equal to 18 volts divided by 3 plus 3 plus 3, right? Again, I'm just trying to show you that this actually works. The shortcut is right here. The shortcut is this. But I'm showing by Ohm's law that the shortcut actually should work. So 18 divided by 9, that's equal to 2. And so yeah, that's the same answer we got before. So from now on, you kind of know if you have a parallel circuit and all the resistors are identical, they're all the same value, that the R total is super easy to find. You just take one of those resistors and you divide by the number. Okay? So one thing I'll put as a question just for you to think about is, like, how many 6 ohms in parallel to get our total is equal to 1 ohm. Right? Think about that for a minute. If you want, pause the video. But how many 6s would it take to give you an overall resistance of 1 ohm? All right, hopefully you've paused the video and you've thought about that. But the answer would be 6. Right? It would take 6 resistors to give you that. And because 6 divided by 6 is equal to 1 ohm. All right? So I hope that helps. And then, keep on working on the things that we have on our playlist. And we'll see you in class.